You ready for my challenge? If my product is 24, and I tell you that one of the factors is 4, what's the other factor? If my product is 24, I see these brains turning on, and one of the factors is 4, what's my other factor? Hands in star. Hands in. Stop. With your partner, you can turn and talk. I want to see your work. See your work on your whiteboard. You have 2 minutes. Go to work.
So it is 28 because I know that a factor is a number that you skip on by to get to the total amount. And when I see 4, that tells me that we're counting by 4s. Because if you had a 26 after this, that would be counting by 2s, and that will change this to another number.
The other factor is 6 because if you count by 4 6 times, then you would get to 24. Also, you could say the other factor is 3 because when you count by 3s, you could get to 24 because 3, 6, 9, 12, 15, 18, 21, 24, and 4 times 6 equals 24.
I disagree with you, Taylor, because that won't match up. That won't match up with the number 4. But 6 will because 6.
Prior to this lesson, we just started our unit on multiplication. So last week, what we talked about was how factors are related factors. So we did a 3-day lesson around the factors of 100, the factors of 200, and the factors of 300. Let's say that I take Taylor's combination. Let's say that Miss Samples knows that 4 groups of 3 gets me to 12. That's my known combination. My known combination. How could I use 4 times 3 to figure out what would get me to 24? How could I use that known combination of 4 times 3 equals 12 to get me to 4 times box equals 24? Turn and talk. Show me on your board.
3 and 3 becomes 6, right? Because you double when you double in the 3. Yes, 3 plus 3 equals 6.
Or 12, and I take that 12 and I double it.
When we double, we know that 4 times 3 equals 12, and you look at the 3 groups, you know that 3 plus 3 equals 6. So then you know that 4 times 6 equals 24.
Your strategy could work because 12 plus 12 equals 24. So if we use the multiplication number sentence, 4 in parentheses, 4 times 3 plus 4 times 3 equals 24. Then at the top of both of these number sentences, we could write the total amount. We could write 12 plus 12 equals 24.
I would say the fluency really comes through because through students' use of using those known combinations that we got to see really nicely, we're seeing that fact knowledge start to develop amongst them. I want you to help me. Can you model on your board what it would look like if you had a 4 by 3 array plus another 4 by 3 array? I want to see if Chester's thinking is correct. Everybody, you can go to work and model this on your whiteboard.
Because I know 3 plus 3 gives me 6, and I know 6, and now I know 6 times 4 gives me 24.
So is what Chester's saying correct? Could we use this 4 by 3 and know that it gets us to 12 and just double it to create 24? What do you think about that? And I don't want a yes or no answer. You know better than that. You need to tell me why.
I know that if you put those 2 arrays together, that will make 6 by 4, and I know that 6 times 4 equals 24.
When we think about students being able to really dive deep into the conceptual understanding of what multiplication is, rather than just having a procedural understanding of how to solve a problem, I think this lesson was good to see because they were able to actually apply multiple different ideas to multiplication to find that missing factor. How else could I have written that number sentence on my recording sheet?
6 times 4 equals 24, and it will equal the same thing because the only thing that you're doing is you're switching it, but it will still equal the same even though you're switching the numbers.
Is there any other number sentences I could write? So I have 4 times box equals 24. Box times 4 equals 24. Are there any other number sentences I could write that would represent this?
24 divided
48 divided by 2. You can say 48 divided by 2 because 24 plus 24 equals 48. And if you put 48 into two groups, that will get you to 24.
I agree with you, Adam, because when you say 48 divided by 2, if you had two groups, you deal out 48, you will get to.
And 1. I heard something juicy, and I want you to tell me what you think about it. I heard 48 divided by 2 equals 24. What do you think about that number sentence?
I know that doesn't match what we're talking about, and I know that when they say 48 divided by 2 equals 24, it doesn't have the factor in it, and it doesn't show what we're really talking about in the problem.
What was one of the factors that I did know, Peace?
One of the factors that you didn't know was 4.
Was 4. So Peace is saying that if I know one of the factors is 4, then that 4 needs to be in my number sentence. Samir, can you build on that thought?
I came up with to do 24 divided by 4 because I know we could do division because it gives us the total. It gives us a total and it gives the amount of groups we need to split 24 in.
I like that Chisiteri and Samir were naming those numbers. So you said 24 was the what?
It was the total amount.
Oh, 24 was the total. And what did you say about the 4, Samir?
It was the total amount of groups we had to split.
The number of groups that you're splitting into. But again, Samir is using the numbers that he knows. So yes, while 48 divided by 2 does equal 24, that number sentence wouldn't match my array. Because remember, you have to use the factors and the dimensions of the array to get to your product. So when Samir and Chisiteri say 24 divided by 4, do I get my other factor of 6? Does that work? Would I get the other factor of 6 that we figured out before? Show me on your board. Go to work.
I think that we should skip count by 4s to get to 24. 4, 8, 12, 16, 20, 24. I think that would equal 6 because when we skip count by 4, you get to 20. You skip count by 4 and you get to 24 by having 6 groups of 4. A lot of these exploration games we've done in years past, and now it's just making sure that we implement them to the same standard and making sure that we're constantly pushing that why and getting our students to talk about the why behind any of the math that they're doing. 30. Oh, it's 30. And one factor, and what's one factor? 5. Did you get it? It's 6. Next, our unit starts to move towards division. So that's why we kind of started posing today that division number sentence and how that can still work if you know the total amount and if you know one of the factors. And so we'll start to dive deeper into that along with the area of a remainder. In addition to that, a deeper unit around the inverse relationship. So how is multiplication, all of this work that we've done, really related to division? Where do you see the connections and where do you see the differences between those?